Look, the era of AI experimentation, it's officially over. Welcome to the Strategic Explainer. We've designed this as a premium executive briefing for enterprise leaders, CISOs, CTOs, and AI governance teams. We've all moved past the initial hype cycle, right? Now, the absolutely critical mandate is bridging that gap between an impressive demo and rigorous, secure enterprise implementation. So today, we're going to unpack the scientific and operational architecture required to deploy AI systems that aren't just highly capable, but verifiably reliable, safe, and secure.
Here is our roadmap for today. We'll be covering 1. The Trustworthy AI imperative. 2. Enterprise model sourcing architecture. 3. Scientific foundations of validation. 4. AI safety versus AI security. And 5. Operationalizing AI governance. Let's dive right in.
Section 1. The Trustworthy AI imperative, focusing on the business and compliance risks of unvalidated models. Before we get into the complex mathematical architecture, we have to establish the sheer business stakes of deploying unvalidated models into production. Let's be real. Trustworthy AI is no longer just some academic checklist. It directly drives your business impact. Deploying unvalidated AI creates unacceptable risk vectors. We're talking about degraded performance, where models drift and suddenly start generating incredibly poor business decisions. You risk a catastrophic loss of user trust and brand reputation through biased or harmful outputs. And from a regulatory standpoint, it's getting strict. Frameworks like the EU AI Act, the NIST AI Risk Management Framework, and ISO 42000 are laying down hard legal baselines for auditability and accountability. Mitigating these risks fundamentally reduces the long-term cost of failures and security incidents, which ultimately gives you a massive, sustainable competitive advantage. To actually mitigate those risks, we rely on the DrPinnacle end-to-end practice framework for trustworthy AI. It establishes a core principle. Trustworthy AI equals an AI system that is accurate, reliable, safe, secure, and fully aligned with your business values. Think of it as a progression. We start with foundational pillars: model validation, benchmarking, AI safety, and securing AI systems. And we carry that rigor all the way through to a continuous operational evaluation pipeline. We're going to break this entire ecosystem down step by step. Moving to Section 2, Enterprise Model Sourcing Architecture, where we define the risk parameter. As your organization scales its AI initiatives, your very first architectural decision literally dictates your entire threat landscape. You have two main paths, each with entirely different governance requirements. On one hand, you have proprietary or hosted models. Think OpenAI's ChatGPT, Anthropic's Claude, or Google's Gemini. Here, the vendor manages the model weights and the infrastructure, so your risk management really needs to focus heavily on data privacy, API security, and mitigating vendor lock-in. On the other hand, you have open source or self-hosted models. These are accessed via platforms like Hugging Face or tools like Ollama and deployed on your own cloud, on-prem, or hybrid setup. Now, you gain ultimate control over your data and customization, but you also entirely own the security perimeter, the infrastructure overhead, and the supply chain risk of those model weights. Your enterprise validation strategy has to adapt based on which architecture you choose. That brings us to Section 3, Scientific Foundations of Validation. It is time to move from hype to mathematical rigor. To truly trust an AI system, we have to move completely away from anecdotal testing. You can't just ask an AI a few clever questions, get decent answers, and declare it validated. That's not enterprise engineering. By grounding our validation in empirical risk minimization, we utilize specific formulas like expected risk. The math basically states that the expected risk is the expected value of the loss function across a given distribution. In executive terms, this translates unpredictable, anecdotal AI behavior into concrete, measurable probabilities. You are no longer guessing. You are scientifically quantifying your actual business risk over time. And this math builds a holistic view of validation. An enterprise model isn't just universally good or bad, it has to be evaluated across highly specific dimensions. For instance, we look closely at expected calibration error, or ECE. This is absolutely crucial. A model shouldn't just be accurate, its reported confidence level must align with that accuracy.
If your AI is 90% confident in a completely wrong answer, that is a severe, unacceptable business risk. We also mathematically validate fairness using metrics like demographic parity to ensure unbiased outputs across sensitive groups, which directly mitigates legal and reputational risks. Finally, we test for robustness. We have to ensure the model doesn't just completely break down when it's faced with noisy data, distribution shifts, or malicious adversarial inputs. Now, to contextualize all these metrics, we must benchmark our models objectively over time. This isn't a one-off task. We utilize standard public benchmarks, sure, but more importantly, we run domain-specific and custom enterprise benchmarks. We apply paired statistical tests to detect any meaningful deviations, and we use effect size aggregations to build a comprehensive, reliable leaderboard. This continuous, statistically rigorous benchmarking ensures your AI deployment is constantly being measured against definitive, scientific baselines. Section 4. AI safety versus AI security. These are distinct imperatives for enterprise protection. This is a critical vulnerability area for executive teams and boards, conflating AI safety with AI security. They are vastly different disciplines, yet deeply interconnected. AI safety is about the ethical alignment of the model itself. The primary goal is ensuring the model behaves safely and aligns with human intent. We're trying to prevent threats like hallucinations, toxic outputs, biased decisions, and jailbreaks. We measure this through toxicity and harm rates. AI security, however, is about hardened cyber defenses. It's the protection of the AI systems, infrastructure, and data from malicious external threats. Here, we are actively defending against prompt injections, data leakage, and adversarial attacks, using traditional threat modeling frameworks like Stride. Listen, you could have a perfectly safe model that is easily hacked, or a highly secure infrastructure running a dangerously hallucinating model. You absolutely must engineer for both. Within that security framework, how do we actually secure data privacy scientifically? Because simple anonymization doesn't cut it anymore. Enterprise-grade systems utilize differential privacy. It's a mathematical guarantee ensuring that an AI system's output does not reveal whether any specific individual's data was included in the training set. By strictly limiting the privacy budget, which is represented by epsilon in the equation, we mathematically guarantee protection against severe vulnerabilities like membership inference attacks. That's when a bad actor tries to extract your proprietary training data directly from the model's outputs. Finally, Section 5, Operationalizing AI Governance. Let's look at implementing the end-to-end framework. We've covered the business imperative, the math, the safety, and the security. Now, we zoom back out and translate these scientific concepts into actual enterprise workflows. Step 1 is defining the use case, risk appetite, and governance policies up front. Step 2 is building or selecting the right model based on that infrastructure architecture we discussed earlier. Step 3 mandates rigorous validation and benchmarking against our mathematical baselines. In Step 4, we perform adversarial red teaming for safety and implement robust security access controls. Step 5 is deployment, but strictly with guardrails and logging fully enabled. And finally, Step 6 is continuous monitoring and improvement. Because, let's face it, deployment is just day zero. The environment changes, your data changes, and adversaries constantly evolve. Your enterprise must operate relentless, continuous evaluation. This means you need to implement SOC or NOC-style dashboards for real-time AI observability. You must proactively monitor for data and concept drift, tracking real-time metrics like calibration error, toxicity rates, and F1 performance scores. And for high-risk business decisions, human-in-the-loop systems are a non-negotiable requirement. Ultimately, all this telemetry feeds into automated feedback loops, which allows you to retrain and improve your models iteratively. As we wrap up this explainer, I want to leave you with a final strategic thought for your board. Are you merely rushing to deploy AI, or are you rigorously engineering it? As the framework dictates, trustworthy AI is not achieved by deploying models quickly. It is achieved through continuous validation, benchmarking, safety engineering, and security governance. So ask yourself, what hidden vulnerabilities are quietly sleeping in your production models today? Thank you for joining this briefing.